Okay, an object near the Earth is subject to a gravitational force that produces a downward acceleration denoted by g. For motion close to the ground, we assume that g is constant, its value being approximately 9.8 meters per second in metric, or 32 feet per second, I should have said squared, in imperial. So I do expect you to know these constants. Acceleration due to gravity, both in metric and in imperial units. Okay, so we're going to do this first question the long way, and then we're going to stop and look at it and summarize a quick way to set up a question like this. A stone is tossed upward with a velocity of 8 meters per second from the edge of a cliff 63 meters high. How long will it take the stone to hit the ground at the foot of the cliff? Okay, so here's the ground, here's our cliff, and it says that this is 63 meters high. And we start here and we throw it up and it comes down. Of course, we're looking at motion along a line. Don't think that this motion, we're not looking at the parabolic motion, we're looking at the straight up, straight down motion. I'm just not drawing it on a line because it would hit the cliff. Okay, how long will it take to hit the ground at the foot of the cliff? So we are trying to answer a question related to time. Okay, so what do we know about this is we know that our initial acceleration due to gravity is pulling that rock down. That is, our acceleration at time t is negative 9.8 meters per second squared. What else does the question tell us? It says we toss it upwards with a velocity of 8 meters per second. And this up means that our initial velocity is positive. And the edge of the cliff is 63 meters high. That's telling me my position at 0 is 63. So how long will it take to hit the ground at the foot of the cliff? Well, what I really want to know is how long until position is equal to 0. So let's get a position function. First of all, velocity at time t is the antiderivative of acceleration. That would be negative 9.8 t plus a constant. So if I want to know what that constant is, I put in the velocity at 0 would equal negative 9.8 times 0 plus c, and the velocity at 0 is 8. So 8 is equal to negative 9.8 times 0 plus c. There's my c value. Here's my velocity at any time t. Negative 9.8 t plus 8. And when you go to your physics class, you make sure you put your units in. Then if I want my position function s at t, I'm going to take the antiderivative of this function. So leave that constant out in front, negative 9.8 t squared over 2 plus 8t plus another constant. I'm going to call this one d. So when I simplify my position function s at t, I get negative 4.9 t squared plus 8t plus d. And if you've been wondering where that negative 4.9 came from when acceleration due to gravity is 9.8 meters per second squared, this is why. It's because you're taking the antiderivative of that velocity, and the antiderivative says you add 1 to the exponent, divide by the exponent, you end up with half of it. Okay, solving for d, well, as you can see, we're putting in position when time is 0 is 63, so s at 0, negative 4.9 times 0 squared plus 8 times 0 plus d. What is the position at 0? 63 is equal to d. So here's my position function. S at t is equal to negative 4.9 t squared plus 8t plus 63. Have we answered the question? No. We're asked how long will it take to hit the ground? Well, we're looking for position. When is the position 0? So that is, it hits the ground if position is 0. So we need to find time when S at t is equal to 0. That is when 0 is equal to negative 4.9 t squared plus 8t plus 63. Just a classic case of use the quadratic equation or plug that in your calculator, your quadratic formula in, and you're getting approximately 4.5 seconds. Okay, so let's just summarize and look at how simple this equation is to come up with. So a position function. This is going to be 1/2 the acceleration due to gravity, 1/2 acceleration due to gravity. This coefficient is V0, and this coefficient is S0. Initial velocity, initial position. Please make sure you pay attention to the sign on this. If you're throwing it down, then your initial velocity would have been negative, but I tossed it up, so my initial velocity was positive. One more question for you. So come to class prepared to answer this question, and set it up like this. So here's the question, and I'm going to give you the minimum amount of information that you need. Okay, suppose you're walking in the pitch black, and you're walking over a bridge, and you're wondering if you should jump into the water below. So what happens if you drop a rock off the bridge? And it hits the water 3 seconds later. My question for you, and I've got 2 of them. Question 1, how high is the bridge you're standing on? And my second question is, if you jumped off that bridge, how fast would you hit the water? So with this minimum amount of information, you drop a rock off a bridge, 3 seconds later it hits the water. You should be able to figure out how high the bridge is and how fast you would hit the water if you jumped off that bridge, and then you can tell me if you would or not. So see you Monday. Don't jump off the bridge.